Aswathi. Welcome to the session of Bernoulli's principle. Bernoulli's theorem states that the sum of pressure energy plus potential energy plus kinetic energy per unit mass is constant for an ideal fluid having streamline flow. Thus, Bernoulli's theorem gives us an idea about which parameter it would depend when the fluid is flowing in a streamline. Let's look at an equation. P plus half rho v square plus h rho g equal to a constant. P is the static pressure term, half rho v square is the kinetic energy term, rho is the density of fluid particle, v is the velocity of fluid, h rho g is the potential energy term, h is the height which elevated, rho is the density of fluid, g is the acceleration due to gravity. The sum of these three terms is constant. Look this pictorial representation. Here I have tube X and tube Y. A fluid is flowing from tube X to tube Y. Suppose if I give some arbitrary amount of fluid in the tube X, the same arbitrary amount of fluid will be coming out from tube Y. Thus, the mass is conserved. So, we can say that the product of area of cross section and velocity of the fluid particle at any two random point will be a constant. This is called the equation of continuity. Thus, A1 V1 equal to A2 V2. A1, A2 are the area of cross section in the tube X and tube Y. V1, V2 are the velocity of the fluid particle at tube X and tube Y. So, here we have larger cross sectional area, here we have smaller cross sectional area. So, A1 is greater than A2. Similarly, here we have P1 pressure, here we have P2 pressure. So, P1 is greater than P2. In terms of velocity, here we have V1 velocity, here we have V2 velocity. V1 is less than V2. The velocity of the fluid particle at Y tube will be greater than the X tube. This is an important point. When the pressure increases, the velocity of the fluid particle decreases. I have an example for you. This is my favorite spray foam. When I compress it, the pressure inside this tube has been lowered. Thus, the velocity of the fluid particle increases and it ejects up the fluid particle. This is one of the application of Bernoulli's theorem. Okay, coming back to our session, here we have to show the conservation of energy. For the conservation of energy, we have to show the work done. So, work done at tube X. Here I have volume V1 and I have volume V2. So, the work done at tube X equal to P1 V1 and work done at tube Y equal to P2 V2. Since the mass is conserved, the volume V1 equal to V2. V1 equal to V2. So, the net work done equal to the difference in work done. P1 minus P2 into V. Since V1 equal to V2. This work done is equal to the sum of kinetic energy plus potential energy. Here I have written the net work done per second equals increase in kinetic energy plus potential energy. Thus, P1V minus P2V equal to difference in potential energy term in the tube X and tube Y plus difference in kinetic energy term in the tube X and tube Y. By rearranging them, and finally we get P by rho plus GH plus half V square equal to constant. This is called the conservation of energy. So, this is end of our session. If you have any doubt, you can mail me. I will give my mail in the description box. Have a nice day. Thank you.